This was one of the hardest A-level maths questions that year. In fact, most students couldn't even get started. The examiners noted that the mean mark out of 9 was only 1.9. Most students were either scoring 0 or very little. In fact, they said it proved to be a challenge for many candidates. Let's read it through. Figure C shows a sketch of the curve C with these parametric equations. Here we are. And we have the domain for t given as well. It says the region R shown shaded in the figure is bounded by the curve, the x-axis, and the line with equation x equals 4. We're asked to show that the area R is given by this, where the limit a here is a constant to be found for part A. How do we get started with this? Well, you should know that we find areas by integrating. We integrate y with respect to x between the two limits, the x values 0 and 4 in this question. So this is our starting point. However, you should recognise that this question is about parametric integration. And there are 3 things that we need to do when we integrate parametrically. The first is to change the y. So how are we going to change this y? Well, we're going to use the formula that they gave us here. So I'm just noting that down here. The second thing that we need to do is to change the limits. At the moment, the limits match here. They match the dx, they're x values, these limits. And we need to change them into t values. How do we do that? Well, we've got this handy formula linking x to t. So when x is 0 in the lower limit, well, we know what x is. X is 8 sine squared t, so that would equal 0. If you divide by 8, we get this. Take a square root, we get this. And in this interval for t, the only value is t equals 0. What about the upper limit? What about when we have x equals 4? Well, 8 sine squared t would equal 4. Divide by 8, we get a half. Take a square root and note that on the interval that we were given for t, sine is always going to be positive, so we don't need to worry about plus or minus signs. We end up with this. And if you apply arc sine, we end up with, in radians, that's really important, not degrees, pi by 4. Remember, when we're integrating, we must use radians. So that's the second thing, changing the limits. What about the third thing? Well, the third thing is to change the dx to be a dt. How do we do that? Well, again, we go back to this. This involves the ingredients x and t. Now, we need a dx, so we're going to have to differentiate this with respect to t to find dx by dt. How do we do that? We take the power, we bring that to the front and multiply it with the 8 to get 16. We subtract 1 from the power, so it's now just sine to the power of 1. We also differentiate t, that just gives us 1. So 1 times 16, still 16. And we also differentiate the sine. That gives us cosine. Cosine of what? Well, it's got to match here. It will be cosine of t. So I want to replace the dx. How do I do that? Well, we can kind of think of this informally as a fraction, multiply by dt on both sides, and we get this for dx. So we're going to use all 3 things. So remember what we started with? We had this as the area. We're going to change the limits. When x was 0, well, now t is going to be 0. And when x was 4, the upper limit, t is pi by 4. So we replace them in turn. What else? We can replace the y value, the y here, with the equation that we had here. So that's going to go in this position. And then we're replacing the dx here with what we had here. So that's going to go in place of dx. Notice now that we have a dt here, and the limits are now t values. We can next expand the brackets in the usual way. So we've got 2 times 16, and then I've got sine 2t, and then this stuff. And then I've got 3 times 16, that's 48. Sine times sine, sine squared, and then a cosine t. Okay, so what have we got here? Well, I'm going to simplify this part a little bit. How? Well, I want to make use of a trig identity. I know that 2 sine t cos t is sine 2t. So I'm just going to replace that in straight away. Why am I doing that? Well, now, can you see we've got sine 2t multiplied by sine 2t? That's going to give us sine squared 2t. Let's take a look at the goal. So we wanted to show that we could write it in this form. Okay, so what do we like? Well, I like that I've got this 48 sine squared cos t, because we've got that here. But what I don't like so much is that I've got a 16 sine squared 2t, when here we've got something else. And notice that the something else involves 4t, not 2t. So that's telling me, I'm going to have to use a double angle formula on this. Let's have a look. So what double angle formula do I know that involves sine squared, and also a cos of an angle that is double this one? Well, I know the double angle formula for cosine, like this. If I rearrange this formula to make this the subject, we get this. Divide by 2, we end up with this. Now, I'm going to replace the a here with 2t, because that's what I've got here. What would 2a be? Well, if a is 2t, 2a would be 4t. Okay, so you see what I've done there? Just replace the a with 2t, and therefore 2a will be 4t. So why have I done all of that? Well, that means that I can replace this part with all of this. And that's going to go in that little slot there. And you'll notice now 16 divided by 2 gives me the 8 that I wanted. If we expand the brackets, we get to the answer that we wanted in the question, with the limit being pi by 4. Part B, it says hence, so that means using what you've just done, using algebraic integration, so we're not allowed to just put this in our calculator, we need to show the working. We need to find the exact area of R. That word exact means no decimals allowed. We need to leave our answer in an exact form with no decimals. So if we have any square roots or pies, we're going to leave those in our answer. Okay, so we can start with what we left off from part A, and we can integrate each term. With respect to t, remember? So this is going to become 8t. And then this term here, I know that if you differentiate sine, you get cosine. Okay, but I've got a 4t, so I need to cancel that out by dividing by 4. And similarly here, how can I integrate this? Well, remember that integration is the opposite of differentiation. And I know that if I differentiate sine cubed of t, well, I'll take the 3 down to the front to get 3 sine, and then it will be sine squared cos t. I want to cancel out that 3, so I'm going to divide by 3. Okay, so we end up with this as our integrand here. Okay, so now it's just a case of substituting in the limits, the upper limit first, and put it in these round brackets. And then the lower limit, if we substitute that in, because sine of 0 is 0, well, all of 3 terms are going to be 0. Okay, and then it's just a case of doing the number crunching. That gives us 2 pi there. This is 0. And then we've got 16 lots of, well, sine of pi by 4 is root 2 over 2. And then we're cubing that. And if you do the number crunching, you end up with this. And we don't want to give it as a decimal, remember, because we want the exact area.